Hi everyone, welcome to my YouTube channel. Today we are going to study content and pedagogy of teaching physical science. This will be helpful for the people who are preparing for the B.ed exam third semester. So first let us introduce the important questions in unit 1. So the important questions are, I'll be starting with questions and solutions, so it will be easy for you to understand and it will be a revision process also. So the question number 1, what is circular motion? This is most often asked and it is asked for 1 marks question repeatedly. So the definitions is, in physics, the circular motion is a movement of an object along the circumference of a circle or rotation along a circular path. So for example, let us consider a circle. If we have an object P, this object moves along the circumference. This is the perimeter or circumference of the circle. Such movement of an object is nothing but circular motion. Let us consider a few examples to understand the circular motion. So, an artificial satellite placed on the orbit above the earth level. It is an object placed above the earth level whose movement is in the circular motion because it covers the circumference of the Earth's surface. So satellite, artificial satellite is an example for circular motion. Ceiling fan, that's a second example where the fan is placed above on the ceiling and the wings of the fan plays the circular motion. That is the second example. And one more example is a car turning a curve in a race track. So we have a car, this is a race track. The car bends this racetrack. This is also a motion called circular motion. Next question, which is important when it comes to B.ed exams, mention the type of circular motion. Just now we defined the circular motion. The next question will be type of circular motion. There are 2 types of circular motions which we need to highlight it when we are writing the exam. So first one among that is uniform circular motion and the second one is non-uniform circular motion. So let us define this uniform and non-uniform circular motion. As the name says, uniform, so there is a proper sequence in uniform circular motion. Non-uniform, you have some acceleration or any other factor affecting the motion of the particle. So uniform motion, you just have to know what is its use. That is, an object will travel in a circular. So we take an object. Since it is uniform, the object travels in a circle with constant speed. So this is what you need to learn. You can elaborate it as much you want. So you just have to compare with non-uniform motion where the object travels or moves in a circle with is not constant speed. So the difference between these two, this moves in a constant speed, this will not maintain the constant speed level. So here comes the example for uniform or non-uniform. The best example for uniform motion is a clock. So question comes, how clock is in uniform circular motion. So clock where the point is fixed and the needles start moving according to seconds, minutes. Even though this needle has acceleration due to movement, but they move in a constant speed in a circular path. So the speed is constant here. So it is an example for uniform circular motion. Non-uniform circular motion is a conical pendulum. So that is where the accelerations are carried on and the speed of the pendulum will not be constant. The uniformity is not maintained in the conical pendulum. Let's come to the next question. What is a wave? So because we have waveforms in physical science, so wave is a medium which can be defined as a disturbance moving through the medium without changing its form. So disturbance has been caused to the medium, but still there is no effect on the medium. We are not going to disturb the medium at all, even though the disturbance happened. So example is, take a stone, drop into the water. So when a stone is dropped, obviously the water get disturbed. But we are not disturbing the water medium. The water medium will remain the same after a while. So this is what we call waveforms. So next question is, what is wave motion? So we know wave is nothing but the disturbance caused, but it is not affecting the medium in any matter. So wave motion is a mode of transfer of energy of a form of disturbance. Here also the disturbance are made to the medium, which travels through an elastic medium due to a repeated oscillation of a particle of medium and their mean position. So the same example we can take, we are dropping a stone to the water place where the disturbance is in the middle, that is the mean position, and the disturbance is carried on. That means the energy has been transformed due to the disturbance and it travels through a elastic medium. As water example, it starts an elastic medium which is flexible. Why it is so? Disturbance are caused due to stone and there is elastic medium due to repeated oscillations of the particle of the medium. So wave motion is nothing but a mode of transfer of energy of a form of disturbance traveling through an elastic medium due to rapid oscillations of the particles. That is the definition of a wave motion. This is highly important because we have one important questions which belongs to this wave motion, that is types of mechanical waves. So where we have two types of mechanical waves, one is transverse wave and longitudinal waves. So mechanical wave, actually how the mechanical waves are formed is, depending upon the direction of vibration of medium, particle with respect to the direction of propagation. So this mechanical waves are being classified into two types. First is transverse waves and second one is longitudinal waves. So most of the question paper has these two questions. As I said, only most of the university question paper will ask the concept or write brief note on transverse vibration and longitudinal waves, or the question can be like, what is the difference between the transverse wave and longitudinal wave? So write few difference between these two waves. These can be questions which you can repeatedly see on the university paper. So let's see few difference between the transverse and longitudinal. Transverse wave, a progressive wave in which the medium particles are vibrating in the perpendicular direction of propagation of wave. So here you need to highlight medium particle are vibrating in the perpendicular direction. Why? Because when we are writing here, the same thing you can repeat, a progressive wave in which the medium particles are vibrating in the, so here we have mentioned perpendicular direction, right? That is for transverse vibration. But here instead of perpendicular you just have to change parallel direction. Same thing, direction of the propagation of the wave. So the first difference here, the medium of vibration is in perpendicular and medium of vibrations are in parallel. That is the first difference you can make a note. So the second point which we can make a note in transverse is, here we have the concept called crust and trough for the transverse vibration. Combination of both only we get transverse vibration. And when it comes to longitudinal vibration, we don't have such crust and trough, but instead we have compression and ray refraction. These are the two concepts which we study in transverse and as well as longitudinal. Transverse has crust and trough, and compression and ray refractions we have in the longitudinal waves. Third point, crust and troughs are produced alternative at the same point of medium. So this is the third point. Whereas when it comes to longitudinal, compression takes place when the particles are close to each other, and ray refraction takes place when the particles are far apart. So here we have crust and trough, and there we have compression and ray refraction. This will be very important point in the difference between the waves. So here is a picture where you can see the difference between the compression and ray refraction. So that is a part of longitudinal waves, whereas crust and trough is nothing but the wave of this form. So I'll just roughly draw it. The peak portion is the crust and the bottom portion will be the trough. So I'll just roughly drawing it. So this part is crust and this part is trough. T-R-O-U-G-H. Okay. So this brings the amplitude. So propagation direction is this. Okay. So if you take the another crust here, so this is what we call wavelength. These are the two waves measuring their points from crust to crust. So actually it has to be equal, okay, crust to crust. Then it is said to be wavelength. So these are the few difference between the longitudinal and transverse waves.